most of you were fine on the first part of your project. Probably the biggest thing I saw was some of you made me graphs without the points connected. I didn't realize that was going to be an issue. That was kind of an issue across the board. So let me show you that real quick. That's an easy fix. Hopefully you saved your graph and saved your file so you don't have to recreate it. If you didn't, then that's exactly what you're going to have to do if you want to get, because you're going to need a graph. We need a graph with everything connected, and this is how we're going to do it. All right. So once you type your data in, and some of you didn't have a 0 starting point, so you might want to just, if you didn't start from 0, 0, if you started recording your data in the middle of a drive, just probably back yourself up, whatever your 1 value or your 0.5 value was, go ahead and make that your 0 value. But here's how you connect. Let me undo it. All right, so a lot of you had this, right? Oh, no, you didn't have that. Oh, so glad that has an undo. Okay, oops, craparola, I keep doing that. Okay, so there's all my individual little data points. If I left click and hold on that, where I can change the color, there's also this little toggle that says lines, and if you turn the toggle on, it connects. Right. We're gonna want this connected because we're gonna do 2 Riemann estimations of the area underneath it. So I want this to be connected kind of neatly. I don't care what color you use, and you can make your line fatter or thinner or whatever you want to do. All kinds of fun things. But that's how you connect your points. You're going to need a printout. You're going to need 2 printouts of your graph. I did ask you to bring that to class today so you could be ready. If you didn't bring it to class today, I can send people to the library as needed. I did a couple different things to print my graphs out, and I'm happy to show you a couple different things you can do. If you don't want to print your graph, you're still going to need to have hard copies of them. So if you prefer to make hard copies yourself, that's fine. But this is what we're going to end up trying to do. And I have this digitally too for you to look at. Is we're going to do estimates, 2 estimates of the area under the curve. Okay. One of your estimates, oops, let's find this. Okay. Here's the directions. Okay, so every person or group, whichever, if you worked with people or just on your own, has to turn in 2 graphs, 2 estimates with your graph. One of them can be either left or right Riemann. So I did a left. And then the other one has to be either trapezoid or midpoint. I did midpoint for mine. 10 intervals of a minute is the consistent thing we're going to do for these 2 Riemanns. So when you turn in your graphs, just like I have, you should have them labeled. If you have a way to do this electronically, go for it. I'm not that savvy with my electronic stuff. I was trying to draw in the Riemann with my mouse and it just wasn't working. If you're good with a draw program and you want to do a Riemann electronically, then you don't have to print them out. But I think many of you will probably print them. So printing out, turning in, labeled with what your method is, showing your calculation, basics. Since we're going to have a consistent width, we can use a little bit of shortcuts for the calculation. My total number of feet and then divided by 5,280. So an estimate of how many miles. And then the same thing with my left Riemann. Okay. After you do those 2 calculations, you're all then going to compare that result to the actual length of your trip, which some of you didn't include. You confuse speedometer and odometer. Odometer is the thing that measures your distance. Hopefully your trip was something that you could maybe recreate so you could at least know what distance it was, because that's kind of a key part of this. Part 2 is going to be worth 10 points. 2 points for each of your graphs, so 4 points total, labeled and drawn correctly and shaded correctly. 2 points for the calculation done correctly, or from each one. So you did when you do a left Riemann, I should be able to check a left Riemann with your data and get the same answer. Same thing if you did a midpoint, I should be able to check a midpoint with your data, get the same answer. And then 1 point for each comparison statement. Here was how I looked at your first part. And for anything that I made a comment about on your first part, if it's something that you can fix it and resubmit it, and I'll re-look at it. Now, I always do better when I have exact things to look at. So here are my graphs, all scanned for you so you can see what I did. Okay. This one, I think I copied and pasted it into a Word doc to print it. No, maybe I did that with one of these. I copied and pasted the graph into a Word doc. The other one I printed directly from Desmos. I'm happy to help you if you need some help figuring out how to get your graph printed out. One of the biggest things I found was making sure I told it to print on landscape versus portrait, and then it worked much better. And then, so you have these two graphy things, and then here's your write-up. I did a write-up. I put my name on it. Okay. I actually edited it a little bit yesterday when I was reading it in 7th period. I realized I wrote some things. Okay, so here's what I wrote. I said, the first estimate I did was a left Riemann. I had several heights of 0, and my rectangles seemed to leave more empty space under the graph, which made me think that this calculation was probably going to be an underestimate. When I first did it, before I even finished the calculation, just drawing in the rectangles, I'm like, ooh, lot of empty space, Plus I've got these 0 parts, so I was just guessing underestimate. And then when I did that, my final estimate using that technique was 4.8 miles. My actual trip was 5.2 miles. Great. If it's more, if it's less, if you thought it was going to be less and it comes out to be more, no big deal. This is not a right or wrong. It's just, this is what happened. You are explaining, like, this is what I thought, and then this is what the calculations said. If you thought one thing and the calculations told you something else, that's fine. If you thought one thing and the calculations validated it, that's fine too. If there's a huge difference between what you calculate here and what your actual trip length was, that's fine. Talk about that. Just talk about whatever happened. The second estimate I did was a midpoint Riemann. There were still small empty spaces under the graph, not covered by rectangles, but there were also places where the rectangles went over the graph. I wasn't sure if this would be an over or underestimate, but I thought it would be probably be more accurate than the left Riemann. So I was thinking when I did my midpoint, I'm like, this is probably going to be closer. Okay. And then I found out, yes, it was very close. My estimation using that was about 5.18 and my 5.2. I want to make sure you have your data available to me in part 2. So putting your data table back in a document for me so I can see it as I'm looking at your graphs wherever they are. I don't want to have to go back and look for your data table somewhere else. So if you can produce your data table again. I didn't have it typed separately, so I just copied and pasted it as an object right out of my Desmos. Now, I typed this because I wanted to have something for you guys to present. You can absolutely handwrite this. You can absolutely handwrite this on the backs of your graphs, you know, and that's not an issue. You know, it doesn't have to be a typed precise thing, but I am going to expect some kind of analysis. When you did this technique, what did you think was going to happen? What does it look like it's going to do in terms of the actual value? And then what did you find? Okay. really, really hard to be wrong here, because it's not wrong as long as you tell me what happened. The only way you're wrong here is not doing it. Okay? Because even if you miscalculate, but then you talk about your miscalculation, that's okay. I mean, I don't love that, but I'm not going to, you're going to lose points for calculating wrong, but you're not going to lose any points for your discussion unless you do not discuss. Okay? All right.